In this video, we'll be going through AP Physics Review number 3. In this question, we have a ship that begins with a velocity of 10 meters per second. If the ship accelerates at a constant rate of 2 meters per second squared for a total of 20 seconds, answer the questions below. So, number 1 is asking us to solve for the final velocity of the ship. Well, in physics, there is a reference sheet for your AP Physics exam, and on that reference sheet, there are 3 main equations you're going to use for this topic, which is called kinematics. So these kinematic equations are as follow. Equation number 1 is Vx equals Vxo plus Axt. Equation number 2 is x equals xo plus Vxo t plus 1/2 Axt squared. And our third equation is Vx squared equals Vxo squared plus 2ax times x minus x naught. Well, you might be asking, what are all these variables? We'll go through all these variables in another video. But what you need to know is v is velocity, x is some type of distance or displacement, a is acceleration, and t is time. So whenever you get a question like this, you always want to list what your knowns are and what you want to try to solve for. Well, it says if it begins with a velocity of 10 meters per second. And whenever we have an initial or beginning velocity, we're going to denote that with a v subscript I. V initial, the I is just representing initial, so we don't get confused with our final. So we know our v initial is 10 meters per second. Then we have our accelerates at a constant rate of 2 meters per second squared. So we know that our acceleration for the entire trip is 2 meters per second squared. So we know a equals 2 meters per second squared. And then finally, we know our time, which is given as 20 seconds. Now that we know this, we see that number 1 is asking us to find the final velocity. And final velocity is going to be denoted as v subscript f. So now you might be looking at these equations and saying that, there's no vi or vf. Well, when you see an O or a 0, that's initial, and just an X is going to be your final. So these are some different ways to denote it, and again, we'll go through that all in a different video. But now you're trying to solve for this. You're given your velocity initial, and you're given acceleration, and you're given time. So this looks like our best equation to use for this question. So let's go ahead and substitute in right now. Well, we know that Vx is what we're solving. So Vx equals, we know that Vi or Vxo is 10 meters per second plus our acceleration, which is 2 meters per second squared times our time of 20 seconds. Well, now we're just going to do simple math and get our answer. We know that 2 times 20 is 40. 40 plus 10 is 50, meaning that we have a final velocity of 50 meters per second. Now let's go ahead and do number 2. Well, number 2 says solve for the total distance traveled. And remember, distance is the total movement of the object, as we stated in our first review video, the total movement of an object without direction. Let's go ahead and go through that. Well, we know that our second equation right here is x, or position, or some type of distance, equals your initial position plus Vxo plus 1/2 Axt squared. Well, we're trying to solve for our distance, so let's just use that equation. So we have x equals x naught, and let's just assume it begins at 0, or wherever it's starting in this scenario is our 0 point or beginning. So 0 plus our Vxo or V naught, which we are given as 10 meters per second. 10 meters per second times our time, which is 20 seconds, plus 1/2 of our acceleration, 1/2 of 2 times our times 20 squared. So now we have 10 times 20 right here, which is 200, plus 1/2 times 2 times 20 squared. Well, 20 squared is just 400, times 2 is 800, times 1/2 is 400. So we have 200 plus 400 equals x. And we know 400 plus 200 is just 600. And again, it's distance, so it's in meters. 600 meters. Finally, we have number 3, which says solve for the final position if it starts at a position of -100. Well, Here, we're given a different type of scenario, but we're going to still be using the information given above. But remember, in number 2, we said that we started at a beginning position of 0. But here we're given that, let's just say, hypothetically, if it started at a position of negative 100, how far would it be after that negative 100? Well, what we would do here is we would again use our second equation. We would substitute negative 100 as our initial position. So let's go ahead and do that. So we have x equals xo. Well, it's given that xo is negative 100 because that's the starting position. Negative 100 plus our initial velocity times time. So we have 10 times 20. And now we also have to add 1/2 times our acceleration of 2 meters per second squared times, again, our time, which is 20 seconds squared. So we already know that this was just 400 plus 10 times 20 is 200 plus negative 100. Well, negative 100 plus 200 is just 100 plus 400. That just gives us 500. This is a position or displacement or distance type of measurement, so it's going to be in meters. So we have 500 meters as our answer to number 3. I hope this video helped, and if you believe it did, please consider like and subscribe. I would greatly appreciate it. Thank you.